Okay, so we're looking at probability. We're looking at compound events. So we see that the compound event consists of two or more simple events. Okay, and you guys have written that note down at this point. This is example 1 on page. Okay, example 1 on page 330. So here we are told that suppose that a coin is tossed twice. Okay, through a two-way table to represent all possible outcomes in the sampled space. So a two-way table, if we look at a two-way table, we look as follows. Okay, just, I think it's now is the table. So for some reason others not doing the table. So if you're looking at a two-way table, what are my outcomes? Well, what is the event use of tossing a coin twice? Okay. So in the first toss, yeah, I'm drawing too many lines here. But on the first toss could be heads or tails. The second toss could be heads or tails. Okay. Not so. So if we look at my outcome, if the first coin is heads, this is now the first coin. If the heads, then your second coin could also be heads. Or it can be, your first coin can be tails, your second coin can be heads. Your third coin can be, and your third option could be heads or tails and tails. Okay, you all understand? So that is a two-way table. You guys understand? It's a two-way table. So in B it says, draw a tree diagram to represent all possible outcomes in the sample space. So if you draw a tree diagram, those are your branches, okay? What are my outcomes for on your first toss? Can be either heads, yes, or tails. What's the probability of you tossing a heads on your first toss? 50%, or 1 out of 2. So what you notice that I put the probability on the branches. Okay. We'll ask for a tree diagram, don't draw a tree in the exam, okay? So this is on the first toss. Can you see that? So if the first toss is a heads, the second toss could be either heads or tails. And what is my outcomes here? The probability of you tossing a heads on the second coin. 1 over 2. 1 over 2. If you toss tails on your first toss, what are my outcomes then? Either heads or tails. That's 1 over 2. 1 over 2. Can you see that, people? So I follow this branch here, so it's 1 over 2 heads, 1 over 2 heads. So my outcomes are as follows. It could be heads, tails, tails, heads, tails, tails. You guys understand? And these are my outcomes. Okay. You guys understand? Then in C it says, using a two-way table and a tree diagram, determine the probability of obtaining. The first question, C, number 1. A heads on the first toss. A heads on the first toss is going to be, what is this? Not so. So heads on the first toss, the probability of heads is 1 out of 2. Number 2, a tails on the first toss. Tails on the first toss, what is that? Also, or 50%, or 0.5. Number 3, Heads followed by heads, which means to say you have two heads. That's all. So if you look at the total outcomes here, we're really talking about the compound event, two events happening at the same time. How many outcomes are here? 4 outcomes. How many contains two heads? 1. So the probability of you tossing a heads and then a heads is going to be 1 out of 4. Do you guys understand? Otherwise you could have worked it out here as well, since this branch here would be a half times a half, which is a quarter. That's going to be a half times heads and then tails a half, which is also a quarter. Heads, which is tails, which is a half times head, which is a half, is also a quarter. And a half times half is also a quarter. Can you see that, people? You could have done it this way as well. Okay. And 2 heads, of course, is going to be that option there. Do you guys understand? So let's take the calculator away there. You guys can see better what's happening. Okay. Let's look at number 4. Number 4, it says a heads and a tails in any order. Heads or tails in any order. Radia, are you okay, Michael? Yes. Give a look here. No? Heads and tails in any order, which means to say you can hit heads first, then tails, or tails first, then heads. So how many of those options are there? There's 1, 2. Which is going to give you heads or tails, or tails or heads. What is that? 2 over 4, which is 1 over 2. Okay, or we could have checked here. It's going to be a quarter plus a quarter. Not so? Which is also half or 2 over 4. Okay. Did you get number 5? Number 5 says no heads. So no heads means to say what? It means tails, tails. Why? Because a heads contains a heads. Heads, tails contains a heads. Tails, heads contains a heads. It's only tails, tails. So the probability of no head. So you see the H with the bar on top means no heads. Okay. So no heads would be 1 over 4, which means to say it's tails only. At least 1 heads. At least 1 heads is now number 6. So the probability here is going to be heads, heads, then tails, heads, then heads, tails. So it's going to be 1 over 4 plus 1 over 4 plus 1 over 4? 3 over 4. Okay. Any confusion there? Sorry? Just somebody on the side said number 6. Lisa Kanya, yes? Decimal, yes, which is 0.75. Can you get the full mark there as well? Yes? Yes? Yeah? It doesn't matter, but what I do is I always put my first simple event here, and then that way is my second event. Okay? So my outcomes I list here. And I say, okay, heads, and that's why I got heads, heads, tails, heads. Can you see? And so on. So if, say for instance, there's a 3-way event. Say there was a spinner, no? And the spinner is spinning on the first spinner is 1, 2, 3, and the second spinner is 2 to 6, or 2 to 5, 6. Yeah, let's say that. Then what I do is, okay, I always some reason or other make too many lines here. But my first event, I leave this blank because that's supposed to overlap there, basically. No? And I go, this can be 1, 2, or 3. Not so. With this down, it's going to be either 2, 3, 4, 5, 6. Can you see that? So there's another compound event. So here you're going to have 1 and 2. Here, 2 and 2. Here, 3 and 2. Can you see that? Then 1 and 3. 2 and 3. 3 and 3 and so on.
Okay, so
Yes? Does it say on yes? Yes. Yeah, the numbers on top are the options of events A, and here are the sorry, not the options, but the outcomes of event A, and here's the outcomes of event B. Or the first event and the second event. That's it. Okay. Let's look at example 2. At the back. Example 2. Which page are we on now? Are we still on the same page? P14. Okay. So here we are told, suppose that the coin is tossed 3 times. The coin is tossed now 3 times. Okay. But draw a tree diagram to represent all the possible outcomes in the sample space. So on my first event, tossing the coin on the first event, what are the outcomes? Heads or tails? So what's my probability here? Of, and here? So tossing the coin the second time, what are my outcomes then? Heads or tails? Which is 1 out of 2. 1 out of 2. If I toss tails on the first toss, what are my outcomes then? It's going to be off. No. So that is your compound event 2. So if you toss it now for the third time, what's going to happen then? Heads, tails, which is off, off, off and off. That's heads, tails. Heads, tails is off and off. Heads, tails, which is off and off. Okay. So what are my outcomes? Yes, Michael.
So how many marks is the tree?
The tree diagram normally like 2 or 3 marks.
And 2 table.
So also 3 marks. Okay. So what are my outcomes if I follow this branch? It will be heads, heads, heads. So what I do is I do it in order so that I don't miss any. Okay. So I go heads, heads, tails. Then heads, tails, heads. Can you see that? I'm not going to go heads, heads because I've exhausted both already. Can you see that? I've used that, I've used that. Now I'm going to use that one, so it's going to be heads, tails, heads. Then heads, tails, tails. Then tails, heads, heads. Then tails, heads, tails. Then tails, tails, heads. Then tails, tails, tails. Right, you guys understand? How many outcomes are there? 1, 2, 3, 4, 5, 6, 7. There's 8 outcomes. You guys understand? So the first question, okay, that's A. B says, using the tree diagram, determine the probability of obtaining 3 heads. 3 heads can only be that one, not so? So that's going to give you the probability of 3 heads. It's going to be 1 out of 8. Can you see that, people? Number 2. 2 tails followed by a heads. 2 tails followed by a heads. So, where is that the case? 2 tails? The 7th one. That's the only one we can consider, not so? Why? Because I didn't say in any order. It says 2 tails followed by a head. So that can only be that one. Not so? So the probability, tails, tails, heads, which is 1 out of 8. Okay. Look at number 3. 2 heads and a tails in any order. 2 heads and a tails in any order. 2 heads and a tail. Number 2 is? 2 heads and a tail. Number 3 is? 5 years. That's it. Not so? So the probability of 2 heads and a tails in any order? 3 over 8. Not so? Right, let's look at number 4. Number 4 says at least one tail, no heads. No, at least one tail. But that's actually wrong. Huh? So it says at least one tail. So if it says at least one tail, then the rest can be. But here it says at least one tail and no heads. So it's only going to be number 8. It had said no heads actually. Because it's either the one or the other, but here they put it both. But okay, let's see. It's going to be 1 out of. Okay, but if it says at least one tails without this, but that's it, at least one tails without that, then how many options are there then? 7. It will be 7 out of 8. Okay, but they put everything together. So I think they were looking at this tails only. Okay. With that you will be able to do exercise 2 for homework. Okay. So I'll give you a chance to do your homework now. I'll stop the video at this point.